Hey there! In this tutorial, you'll learn how to create a box plot, bar plot, and scatter plot using ggplot2 in R. First things first, we need to load up the ggplot2 package. The easiest way to do that is just to type library tidyverse. Why tidyverse? Well, it's basically a super handy collection of essential packages, like dplyr and ggplot2, all rolled into one. So, loading tidyverse gets you all set. R includes a wide variety of built-in datasets. To see a list of them, simply type data. You'll notice there are many datasets available. To open and view a particular dataset, use the View function and specify the dataset's name. For this tutorial, we will be using a dataset named chick weight. This dataset consists of two columns. The first column contains the weights of the chicks, while the second column lists the different types of feed given to these experimental chicks. Now, to create a box plot, first write the name of your dataset followed by the pipe operator. You can use Ctrl+Shift+M or CMD+Shift+M on Mac as a keyboard shortcut for the pipe operator. After the pipe, type ggplot. Inside ggplot, there's a function called AES, which stands for aesthetics. This is where you specify the plot's axis. Let's use feed for the x-axis and weight for the y-axis, and set fill equals to feed to assign different colors to each feed type. Observe that we have generated a blank canvas, though the specified axes are visible on the graph. To incorporate a basic box plot, utilize gmboxplot within the code. As we can see, the whiskers of the box plot currently lack error bar caps. To add these caps, we'll use the following code. The ggplot2 package constructs plots in a layered manner. Consequently, the order in which code elements are specified dictates their rendering order. To position the error bars beneath the box plot, one should place the code for generating the error bars prior to the code for the box plot. To modify the width of the error bar caps, utilize the width parameter within the error bar function. Now, let's add jitters to the plot using gmjitter. The visual aesthetics of the graph can be altered by applying various themes. While ggplot2 offers numerous pre-built themes, we shall utilize the minimal theme for this demonstration. Furthermore, themes can be employed to eliminate the legend, as demonstrated by the subsequent code. To modify the font size of all textual elements present in the graph, utilize the base size argument within the theme function. Creating a bar plot requires calculating the mean and standard deviation, which will be used as the plot's data. To do this, first select your data and use the pipe operator. Next, group the data by feed type. Then, after another pipe, use the summarize function to create new columns for the mean and standard deviation. Assign this newly created data to new chick weight variable. Now, to create a bar plot, we will use our new chick weight data. First, write the name of the variable followed by the pipe operator. Inside the aesthetics, use feed for the x-axis and mean weight for the y-axis. Then, use gmbar to create a simple bar plot. Within the gmbar function, set stat equals to identity so that it uses the exact values provided in the dataset. Now, let's add error bars on top of the bar plot. We will use the standard deviation values that we calculated previously. You can also use standard error to plot on the bar. By using gmerrorbar, we will specify the y minimum and y maximum values inside the aesthetics function. Change the width of the error bar using width function. To label each axis, proceed as follows. Designate the x-axis as type of feeds and the y-axis as mean weight of chickens. As you can see, the text on the x-axis is overlapped. Let's fix this issue. we will use axis text x and, within it, the element text function. Inside element text, use the angle argument to change the text rotation, and also adjust horizontal justification as needed. To create a scatter plot, we will use another dataset called iris. Here, we will examine the correlation between sepal length and sepal width and visualize it using a scatter plot. To create the scatter plot, first define the axes, which will be sepal length and sepal width. Then, use ggpurb to create the graph. As you can see, all the species are plotted in a single graph. We can separate them using the facet wrap function. Use facet wrap and, inside it, specify species to separate the plots according to the species. To eliminate these gaps within the graph, set the scales argument to free. We can also add a trend line inside the graph using the gsmooth function. Don't forget to specify the method as linear model. Now, to add the correlation equation to the graph, use the statCore function and specify the method as Pearson correlation. Before doing that, you will need to load the ggpurb library.